Practice reactions of amides. Okay, so I encourage you to pause the video and try to work out these reactions before I do, and then check your work with mine. But okay, so just a reminder that to get amides to react, we need an acid catalyst and heat. That's just because this amide group is so unreactive. It's a very strong base. There's just not a whole lot that can replace it. So here is our amide, and let's react it with water. And like we said, we know we need an acid catalyst, so we can put an acid in there, and heat. This triangle here just means heat. Okay, so typically reactions like these, when you're using water, they tend to make an OH group at the end of a molecule like this. And in this case, with our other functional groups, this carbonyl carbon here, that would give us a carboxylic acid. So hopefully we can just visualize how, and let's draw the side product for this right quick. It would be NH3 plus CH3, like that. So hopefully we can just visualize and see how we're losing one of these hydrogens here and just adding the OH that's left onto this molecule. And yeah. Okay, so let's try another one. Let's just do NHR, just because that could be any group of carbons there. It's still going to react the same. Okay, so let's react it with this alcohol, like this. And we know it's going to need HCl and heat. Again, because this amide group is so unreactive, it needs that extra boost to those acid and heat to replace it. Okay, so we know that just by looking at it, it's just going to replace. We're going to lose this hydrogen here and add on this group. 1, 2, 3. Right, 3 carbons there, and this is an ester functional group. There we go. So hopefully that's easy just to visualize to see what's going on. Okay, again, our side product for this would be an HR plus, or H3 plus, if you need to know those. Again, we're just adding at the electronegative atom here, and then put in the rest of the carbons and drop in the hydrogen. Okay, so let's try another one. Okay, so say we were reacting this with methanol. And again, our acid and heat. What happens? Okay, we know we are adding right here, we're dropping the hydrogen, and we're replacing this whole group there, which would give us, there's our oxygen that we're adding at, OCH3, just like that. That's our major product of that reaction. Okay, so moving on, let's try a retrosynthesis problem. And this is really just about visualizing and going on. I love these retrosynthesis ones. I think they really help. To really shows that you really understand what's going on. But so let's do this, and let's make sure it is coming from an amide. how would we build this molecule from an amide? Okay, well, we know it's from an amide, so let's just go ahead and draw, and I'll put it in blue here. Let's draw it in amide. We know that's all you really need, an NH group, the carbonyl like that. Then to make it simple on ourselves, we could just, you just keep this molecule the same here. It's just, a big R group there. And then you could have, any group of carbons there. We'll just put R, any carbon chain attached to that amide, really, and it would still be replaced with what are our reactants for this. Remember, OH comes from water. H2O, we just add that hydrogen back on, and then we know that we need acid catalysts as well as heat to make this reaction work. So there we have it. Hopefully that's easy just to help visualize what's going on, see how we can just replace what we're adding with that without having to do the whole mechanism. Yeah, there it is.